Module 12, Snapshots. In this module, we want to understand what virtual machine snapshots are. We're going to take a look at the impact upon VM performance that snapshots have. Take a look at snapshot files in the directory where the virtual machine files are stored. We want to understand some practical use cases for snapshotting, as well as some limitations and caveats. So snapshots allow administrators to preserve the state of a virtual machine at any point in time so that state can be reverted back to, and there's numerous uses for this. Snapshots can preserve a virtual machine's virtual disk, the virtual hardware settings, VM memory, and the power state at the time the snapshot is taken. One thing to note, as you're taking your snapshots, it's useful to put the word before in the description field or the name field for the snapshot you're taking. For example, if I have a virtual machine, I'm going to apply a Service Pack 10 to Windows. If I just put Service Pack 10, the snapshot name, it's really unclear whether the snapshot was taken before Service Pack 10 was applied to the virtual machine or after the fact, showing that the snapshot was taken after the application of Service Pack 10. So simply putting before you make the change there helps clear that up. So with snapshots, we can revert to a snapshot at any time, thus reverting the virtual machine to its state at the time of the original snapshot. As of Virtual Center 2.5, RDMs and independent disks are not supported for snapshots. In fact, that's kind of the idea behind independent disks, as you'll find in the storage chapter, is to exclude certain disks from snapshots. While this may be helpful in certain situations, it can also be problematic in others. Theoretically, snapshots can be nested up to 32 levels deep, but you need to understand that the existence of snapshots has an impact upon virtual disk performance, and we'll see how in the next few slides. So the way that snapshots work is that we're about to make a change to a virtual machine. We invoke a snapshot, and the virtual disk or the .vmdk file is placed into a read-only mode. All changes thereafter are placed in a delta file or a change file for the virtual disk. As we take additional snapshots or nest them, as VMware calls it, each preceding delta file becomes read-only, and only the new delta file is read-write. So as we look at this in more of a graphical way, we have the original VM, and on the left side of the diagram, header number 1, has a typical VMDK. We invoke a snapshot, so now we have a read-only VMDK, which is the bulk of the virtual machine, and all the changes are taking place in the delta file. If we invoke an additional layer of snapshotting, let's say, for example, that you have several service packs to apply to an application, so you invoke one snapshot, apply the first service pack, invoke a second snapshot, apply the additional service pack, and so on. What happens is each succeeding file gets marked read-only except for the most recent delta file. And this is really what enables us to be able to roll back to any point in time during the snapshot history. Now the challenge of this is that all the delta files must be amalgamated and presented as a unified disk to the virtual machine. So amalgamates are vocabulary word of the day, to merge into a single body or present as a whole. So we're taking these, recall that the virtual machine is unaware of all this activity. The virtual machine sees a drive C or a drive D or whatever it is. ESX server has to take this original VMDK plus the delta files and dynamically amalgamate them, present them as a single unified whole to the virtual machine on demand. And this simply adds to utilization of the ESX server, and it lessens performance of the virtual machine in question. Now, delta files are created and expanded in 16 meg increments. So for example, if we save a file to a delta file that's 16.5 megs in size, it's going to increase it by 16 megs, giving us a 32 meg delta file. Now some use cases for snapshots. What if you're updating or making major changes to a virtual machine? Using a snapshot beforehand guarantees that if you make a mistake, you can quickly revert back to your previous state. For development teams, snapshots can be useful as you roll out different executable, different compiled versions of code. You can test it out. If you don't like the results, you can quickly and easily revert back to the previous state of the virtual machine. Troubleshooting and tech support. Let's say that you're on the phone with your favorite vendor and they're recommending that you make some very dramatic changes to a virtual machine that's hosting a mission-critical application. Well, no problem. You take and you invoke a snapshot, you make all the changes they want, and if something blue screens a box, crashes it, lessens performance, whatever, you can very quickly and easily revert back to the snapshot. Now, do be aware if you do this that any data that came in during the time the snapshot was invoked will be lost, but at least it'll get you back to a stable virtual machine. In the virtualization industry, a lot of backup and replication applications leverage snapshots to do what they do. For example, there are replication tools out there that if you set up replication every 2 hours, the replication software will invoke a snapshot. We'll just say we're starting at noon here, and let that snapshot exist for the next 2 hours. Then we'll invoke a second snapshot to capture all the changes during the next 2 hours in an additional Delta file. Now, while that's taking place, it can take the original Delta file, begin to copy those changes over to the remote DR site or wherever the VM is being synchronized to. And once all those changes are committed, they can delete that snapshot, commit it back into the VMDK, and that process continues as long as replication is taking place. So again, be aware that many virtualization, backup, and replication tools leverage snapshots, a different part of their processes internally. Now also, we want to be aware of some caveats and limitations, or what I call virtualization common sense, right? We want to be aware of the activity that's taking place inside the VM when we invoke a snapshot. For example, if we have a large 30 gig file transfer taking place to the VM, and we invoke a snapshot halfway through that process, and at some point in the future, if we need to revert to that snapshot, well, the VM is going to revert to its exact previous state in the middle of a file transfer for a conversation that has long since disappeared on the network. So the chances are that file will, of course, not be fully transmitted and the file transfer will fail. On the other hand, if we have database transactions that are mid-process being committed, and we invoke a snapshot during the middle of the day while users are using a very busy database, we may end up with partially committed data if we ever need to revert to that snapshot. Now, if we do this, the database is going to see partially committed data without proper checksums. It's probably going to toss the database out and generate some kind of error saying that we need to run consistency checks. So just be aware of this. If you have a large database, you want to invoke a snapshot on that box, that's fine. Just stop the database service or something like that to guarantee consistency of data while you invoke the snapshot. Now, if you know, for example, that a VM is being used to transfer large files to it, just wait to invoke the snapshot until that process is done. Now, a few more caveats and limitations. No snapshots are available for RDMs. If you think about it, that kind of makes sense, right? An RDM, or raw device mapping, is the ability of a virtual machine to use raw disk space instead of a VMDK. So there is no VMDK to put into read-only mode and then therefore generate a Delta file and so forth. And so that's not supported. Okay, and then also if you're using snapshots as a method of updating applications and providing failback, be aware of a few things. First of all, resetting the snapshot will reset all data, not just the application files. We're taking this entire virtual disk back to the state at the time we invoked the snapshot. And not only that, but the memory state of the virtual machine in many cases as well too. So anything that took place after that time will be lost. Now, if you use non-persistent disks to exclude certain disks from snapshots, and let's say that in the example at the bottom of the page here, if only application virtual disks are included in the snapshot and data disks are excluded, if you revert the snapshot to the previous application state, well, now all of a sudden you may have data for a newer version of application that's been reverted to an older version. With databases in particular, this may and probably will cause all kinds of consistency problems and issues. So, VMware gives you the ability with non-persistent disks, with independent disks, to exclude certain disks from snapshots, but just be aware of the implications of doing this because it can definitely cause problems in your IT department.